Hi guys, it's Miss Wilkerson here to give you your weekly science lesson. And we're going to be talking about states of matter, okay? Our solids, liquids, and gases. We're going to dive a little bit deeper than just what they are because we've known the states for quite some time, right? We learned those even when we're in kindergarten. So I'm going to share my screen here. And I am going to show you guys a PowerPoint here that I've made that just talks about the states of matter. Now, on this first slide, you're going to see it says TEAC 3.5b. And what this is what the state kind of guidelines and tells us what to teach. And this is kind of lets you know what you're expected to learn. And so it says the student is expected to describe and classify samples of matter as a solid, liquid, and gases, and demonstrate that solids have a definite shape and that liquids and gases take the shape of a container. And so that's some of the things that we're going to learn today. So what is matter? Matter is anything that takes up space and has mass. Mass is the amount of matter something has. So I am matter. You are matter. We take up space. How much we weigh, how much mass we have in us is the mass, how much we weigh, okay? Everything you see, smell, or touch is matter. Many things you cannot see, smell, or touch or matter too. Air is an example of matter. You sometimes cannot see, smell, or touch. So air is around us. Air's matter. Air takes up space and it has a mass. What are properties of matter? A property is something about matter that you can observe with one or more of your senses. Some properties of matter are size, shape, color, texture, hardness, and whether an object sinks or floats. For example, properties of a basketball could be large, round, orange, bumpy, and hard. So remember, a property is a way that you can describe an object. So we're going to look around the room that you're in right now. You won't get up out of your seat. We are going to use different properties of matter to describe some objects, okay? So I've done one as an example, and I've said the window. And I'm going to use the property of shape to describe it. Now, where I am right now in my classroom, my window is rectangular. I know at home, my windows are also shaped as a rectangle. Now, you are going to look around where you are, and we're going to find some objects for you to describe, okay? So I want you to just, from where you're seated, I want you to look and put your eye on an object, okay? Find that object. Do you see it? Okay, we're going to use the property of size, and I want you to describe your object using the property of size. Can you describe it to me? Very, very good. Okay, I want you to find a second object. It's got to be different, okay? Look around. Let's find a different object. Just real quick, it doesn't matter what it is. Put your eyes on it. Now use the property. We're going to describe it by color. What color? Describe to me, what color is the object that you see? Awesome. Good job. Now let's find a third object. Find a third object. I wonder what the texture of this object is. This, you might have to touch it unless it's something that you know. Like I know if I were to rub the top of my desk, it's a smooth surface, okay? So describe the texture of that object. If you don't know exactly how to describe it, you may need to feel it. Good descriptive words, guys. And one more time, you're going to find an object, and I want you to describe its hardness. Now, the hardness of an object. So say I have my chair, right? And my chair, it's pretty squishy. It's a pretty soft, hard. It's not too hard. If I were to describe My class, that has a very good hardness. It has more hardness than the chair, right? All right, y'all did a great job describing the different properties of the different objects. So what are the states of matter? States of matter are the forms that matter can take. The three states of matter are solids, liquids, and gases. In solids, particles are packed tightly together. In liquids, particles are held together less tightly. And in gases, particles move about freely. So let's look at these examples, okay? So in a solid, particles are packed very tightly together. So let's look here. This is packed pretty tight. See those little particles? They're smushed in there together, right? They're kind of packed in there. And then you have a liquid. Liquid, they're still, particles are held together, but not as tightly. So they're kind of laying on top of each other, but not so tight that they are standing and squished together. So there is what the liquids, particles in a liquid look like. Now gases move about freely. So those particles are everywhere. When you have particles in a gas, they bounce around and they are moving all of the time, okay? So that's even going on right now around you there. Those particles are moving so freely and bouncing quickly around you. Solids are made of those tightly packed particles. Solids have their own shape. You can easily measure both the mass and volume of solids. So your science textbook is a solid, right? It does not change the shape. You can measure its mass and volume, and its particles are tightly packed together. So I have my science textbook here, and it is a solid. And it tells us that its shape cannot change, and that's true. Could we change this shape if it were a liquid or a gas? Does this change its shape? If I were to put this into a bathtub, is the shape of the boat going to change? No. Solids always keep their shape, okay? They always keep their shape. They never change. Particles in liquids are held together less tightly, and the particles in a liquid flow past one another. Liquids take the shape of their containers. If you pour liquid from one container to another, the liquid will take the shape of the new container. And you can easily measure the mass and volume of the liquid. So what this is meaning is if I took my cup of my Diet Dr. Pepper, right, when I first poured it in here, it was already in a bottle. And that liquid was the shape of that Dr. Pepper bottle. And then I took it and I poured it in this. And guess what? The liquid changed shape. It formed to the size of the cup. Just like if I were to take this and pour it into a long bowl, what's going to happen with a Diet Dr. Pepper? It's going to take the shape of that long bowl. Whatever we do with the liquid, wherever we put it, it takes the shape. Just like if I put water from a bucket and I pour it into a bathtub, that water is going to take the shape of that bathtub. The tiny particles that make up gases are far apart compared to the solids and liquids. The particles in gas move freely and take up the space of their container. The particles of a gas bounce off of one another as they move freely, and all matter has mass. So gas has mass too, okay? You can measure the mass and volume of gas. So this also takes the shape of its container. So let's think about the air around us in a room. That air, that gas that's around us, it's taking the shape of the room. An example that you can see a little better is blowing up a balloon. If you had a balloon and you blew it up, what would happen to that balloon? It takes, that air expands, and the air inside takes the shape of that balloon, its container. All right, we are going to watch a Crash Course Kids video. I love Crash Course Kids. So what I'm going to do is I'm going to open that video up for you. Give me just a second here. Okay, hope you guys enjoy this. I think she does an excellent job of taking concepts and really breaks it down and has a great way of explaining it to us. Let's listen.
Let's say my friend and I have just gone to a birthday party, and we each got a gift bag that's full of candy. And my friend makes me an offer, one that I can't refuse. She says I can have any one piece of candy in her bag, but I can only take it without looking. Now, say I'm into gummy frogs. They're my thing. That's what I want. Fortunately, I have a secret. A science secret. When I reach into the bag, I can use the properties of the candy to help me guess. If I want a gummy frog, I'm gonna feel around for something that's kind of small, squishy, and, you know, frog-shaped. But how else can we use this idea? I mean, in other non-candy related contexts. Does it work on school supplies? Breakfast cereals? Hardware? I mean, what exactly can we tell about an unknown substance by its properties? We already know that a substance is matter that's made of one kind of atom or molecule, and that has specific properties, and that some substances are elements, which means they can't be broken down into other substances through physical changes or chemical reactions. We also know that we can group substances and elements by their properties, like we found that all of the metal things from the bottom of my backpack were shiny and attracted to a magnet. So, metals have high reflectivity and magnetivity. What else do we know about metals? If we think back to our lunch investigation, we know that metals are good conductors of heat and electricity, and metals are often silver or gray in color. Let's try another substance. What are some properties of gases? Let's think way back to some of our first videos. When we talked about gases, we learned that gases have no definite size or shape. The molecules in a gas spread out to fill the container they're in. Gases are usually transparent, too. Light passes through them. If we think about some of the gases we know and love, like carbon dioxide and oxygen, we find that they have these properties. Both of these gases fill up the space they're in and are transparent. Gases and metals are just two examples of groups of substances that have specific properties. And because the properties are pretty specific, they come in handy when we're trying to find out about an unknown substance. So, let's get the investigation rolling. Say we have two unknown substances. Both look the same, kind of whitish and powdery. How can we tell them apart? Now would be the time to go over a truly important scientific rule. No tasting. Ever. Right, since that's out, what should we do? Think back to our picnic. Remember what we tried to do with sand and with sugar? We tried to see which dissolved in water. So if we took a spoonful of each unknown substance and tried to dissolve it, the one that dissolved would be the sugar. One of the properties of sugar is that it dissolves in water. Sand, as anyone who's been in the ocean will tell you, does not dissolve in water. It just gets into our bathing suits. But now it's time to level up. This time we'll look at two mystery objects that are totally hidden from view. Our mission, should we choose to accept it, is to find out which one is metal. If we use our sense of touch, we can tell that object A is not very flexible. It doesn't flex or give when I press it. Object B, on the other hand, is pretty malleable. It squishes when I touch it. Ew. So far, we can make the guess that A is metal, but in science, the more evidence, the better, because malleability, or the ability to change shape, is actually a property of some softer metals. So we need more data. Let's bring in our trusty magnet. As you can probably see, because I can't, object A seems to be attracted to the magnet, while B isn't. So, object A has the properties of being hard and being attracted to the magnet, so we're going to guess that it's the metal. And we're right. Object A is a big old nail and B is, hey, my gummy frog. So, substances and elements have specific properties, and because of this, we can use properties like hardness, malleability, or magnetism to tell something about, or even to identify, unknown substances. It doesn't matter if it's candy or handy hardware. And I'm out of gummy frogs.
All right. Let me bring that down just a second. Give me just a second, my friends. All right. I'm going to share my screen back. We are going to do a quick review here, okay? And let's see what we've learned, okay? So remember that a solid, we have those particles and they're packed real tight in there, okay? It's a fixed shape. It's a fixed volume, how much it is. That's a solid. It doesn't change. Liquid, okay? It's not as packed tightly. They're a little bit looser. Those particles are a little bit looser. There's no fixed shape because remember, a liquid can turn into any shape that it's presented to. It makes forms the shape of the container, but there is a fixed volume, which means however much is Dr. Pepper's in here, if I pour it in a bowl, it's gonna be the same amount of Dr. Pepper. Pour it in a bathtub, same amount, okay? And then we have gas. Gas, those particles are moving freely through the air. It has no fixed shape and no fixed volume. So we're gonna do a review together. If we hear a chime, that means we got the answer right. If we hear an explosion, that means we got the answer incorrect. Which state of matter has a definite volume, but not a definite shape, okay? That means it has a volume, it has a definite size, right, of how much mass it has. But it does not have a definite shape. It could be a solid, a liquid, or a gas. What do you think it could be? It's a liquid. We just talked about it, right? It has the same volume. Whatever's in there, it's going to be the same amount, but not a definite shape. No matter where I pour it, what container, it's going to take the shape of that container. Which state of matter has definite shape and volume? Its shape doesn't change, its volume doesn't change, it stays the way it is. It's going to be a solid, a liquid, or a gas. What do y'all think? It's a solid. Remember we talked about it, the shape doesn't change of a solid. If I took my table and I placed it into a pool, does my table change to match the shape of the pool? Nope, it's a solid and it is going to have its definite shape. Which state of matter do molecules move quickly and bounce off of each other? Okay, these molecules, ooh, they are free, they are moving and bouncing. Is that going to be a solid, a liquid, or a gas? It's going to be our gas. All right, some vocabulary. Anything that has mass and takes up space is called matter, mass, or property. Anything that has mass and takes up space is called, it's called matter, my friends. Size, shape, color, texture, hardness, and whether an object sinks or floats is called a matter, mass, or property. We talked about this when you looked around where you're sitting. You picked different objects, and we talked about the texture and color of them and shape. What were we describing there? Describing their property. Good job. The amount of matter something has is called matter, mass, or property. You already know it's matter, and the amount of matter it has is called mass. All right, 2 more and we are finished. Can matter be something you cannot see? Yes. Remember, air is all around us, and air is matter itself, right? So the answer is yes. It says, look at the object, tell what material you think it's made from, and describe its properties. So let's look here. We know we have a balloon. How do you think the balloon feels? Do you think it feels smooth, bumpy, rough? What about the color? Could we describe its property by its color, its size, its shape? Give me some properties that just describe this balloon. All great properties, yes. Guys, thank you so much for joining today. This lesson also goes with our science lab for the week called Magic Balloon. And it has to deal with our liquid, our solid, and our gas, and our states of matter. And I cannot wait for you guys to see it. I hope you learned something new today. See you next time.